Hello, good morning, and thank you for the opportunity. My name is Alisa Annabel binti James Pekan, matrix number 86283, and today I will be presenting the first part of our project on behalf of my team. To begin, this slide provides an overview of our project team structure. It shows how responsibilities are distributed among team members, what deliverables each role is accountable for, and the time frame during which each member contributes to the project. Starting with the project manager, Amanda Natalia Pudang is involved from the month 1 until month 6, covering the entire project life cycle. Her responsibilities include defining the project scope, objectives, and schedule, overseeing resource and budget planning, and continuously monitoring project progress and risks. This full duration involvement measures consistency in decision making and effective control throughout the project. The finance analyst, or me, myself, Alisa Annabel binti James Pekan, contributes during month 1 to month 2 and again in month 4 into month 6. In early stage, my role focuses on budget preparation, cost estimation, cost benefits, and return on investment analysis to assess project feasibility. My later involvement involved financial performance to be reviewed and validated against actual progress, ensuring the project remains financially viable. Crescentia serves as the documentation editor and technical support with responsibilities spanning from month 1 to month 6. Her role ensures that all project documents are consistently updated, properly version controlled, and technically accurate, while also supporting system maintenance documentation until project completion. Norazila acts as the technical lead, contributing from month 1 to month 4. Her responsibilities include defining the system architecture, selecting appropriate technologies, and preparing technical feasibility justifications. This time frame aligns with the core technical phase design of the project. Finally, Siti Norliana is the business analyst involved during month 1 to month 2, focusing on stakeholder requirements, functional requirements definition, and establishing the measure of value, or MOV. This ensures that the project objectives are clearly aligned with stakeholder needs before technical and financial decisions are finalized. Overall, this team structure demonstrates a clear alignment between roles, deliverables, and timeframes, ensuring efficient coordination and successful project execution from start to finish. Thank you.
Hello everyone, my name is Amanda Natalia Pudang. Today I will present summary of MOV. The goal of this project is to enhance DBKU's operational efficiency, environmental sustainability, financial performance, and customer satisfaction. By implementing route optimization and IoT-enabled monitoring, DBKU aims to make its operational faster, more cost-effective, and scalable for future growth. Within 6 months after full implementation, the project targets a 20% reduction in fuel consumption, 15% reduction in greenhouse gas emission, 20% reduction in operational costs, 35% improvement in collection response time, and 10% increase in citizen satisfaction.
Next, I will briefly go through the alternatives we considered for this project. We look at 3 different options before deciding on the most suitable option for DBKU. The first option was the status quo, or as known as do nothing, which means continuing with the current manual waste monitoring process. This option doesn't require any upfront investment, but it also doesn't solve the existing problems such as inefficient collection routes and slow response times. The second option, which we chose, is an off-the-shelf smart waste monitoring system. This solution uses proven technology, can be implemented relatively quickly, and comes with lower technical risk. It also meets DBKU's operational needs and supports the project's goal much better than the other options. The third option was custom system development. While this will give full flexibility, it will take much longer to develop, cost more, and involve higher risk, which isn't ideal for our project given the project's constraints. So overall, we selected the alternative 2, which is the off-the-shelf solution, because it gives the best balance between cost, implementation time, risk, and value for DBKU.
This slide shows the deliverable structure chart or DSC for our Smart Waste Monitoring System project. The DSC shows all the main deliverables of the project. It combines project management work and system development work. The project is divided into 5 main phases, starting from planning until evaluation. Each phase produces an important output such as the business case, project plan, system deliverables, and the project closure report. For system development, we use the waterfall model. This approach is suitable because the project requirements are clear and also supports proper documentation for a government project like DBKU. Overall, the DSC helps ensure the project is organized, well managed, and completed successfully. I will now explain the total cost summary for our project. The biggest cost is staff, which is 97,480 ringgit. The second largest cost is vendors and software providers at 78,000 ringgit. We also allocated 50,000 ringgit for hardware and sensors, 5,000 ringgit for a 6-month cloud license, and 3,000 ringgit for facilities and training. This brings the total project cost to 175,480 ringgit. Originally, the project budget was 200,000 ringgit. By managing our resources carefully, especially staff usage, we managed to save more than 12% of the budget. Overall, the project is cost-effective and remains within the approved budget.
Greetings to Madam. My name is Siti Nurliana and I will be presenting the schedule and budget comparison as well as the project risk identification. The original project schedule was 130 working days. Based on the client's requirement, a 10% reduction was applied, resulting in a revised duration of 117 working days. The project start date remains unchanged while the end date was brought forward from 1st May to 14 April 2026. The schedule structure, including the work breakdown structure, Gantt chart and finish to start task dependency remains unchanged, and the critical path was shortened proportionally. For the budget, the original project cost of 175,480 ringgit was reduced by 20%, resulting in a revised budget of 140,384 ringgit. The resource-based costing approach was maintained, with staff, technology, and facilities costs reduced proportionally to optimize overall budget control without affecting project scope. Finally, key project risks were identified across different project phases. This includes stakeholder expectation misalignment, cost and schedule estimation risks, technical compatibility and sensor installation issues, and end-user resistance. Each risk has a signed owner and is mitigated through early requirement validation, progress monitoring, pilot testing, buffer time allocation, and user training to ensure the project remains on track.
And now, this slide will explain our conversion strategy, which refers to how the new system is introduced into the existing environment. We adopted a pilot-based gradual conversion strategy to reduce implementation risk and minimize operational disruption. In the first stage, the system is implemented in a selected pilot area, which allows us to test core functionality, system performance, and user interaction in a controlled environment. Any technical issues, usability problems, or performance gap can be identified and corrected before full deployment. Once the pilot implementation is successful, the system is gradually deployed across operations. This phase rollout ensures that users have time to adapt, training, and can be conducted progressively, and system stability can be monitored continuously compared to direct or parallel conversion approach. This strategy provides better risk control, lower operational impact, and higher user acceptance. Therefore, this conversion strategy ensures a smooth transition from the existing process to new system while maintaining service continuity.
Last but not least, This project is evaluated using several measurables of value to assess its overall impact. First, operational efficiency. The system aims to reduce fuel consumption by 20% through optimized routes, evaluated 1 month after deployment. Second, environmental sustainability. Greenhouse gas emissions are expected to decrease by 15%, measured through emission estimate based on reduced collection frequency and optimized routing within 3 months. Third, financial performance. Operational and maintenance costs are targeted to drop by 20%, assessed through financial reviews 6 months after implementation. Fourth, service quality. Waste collection response time is expected to improve by 35%, measured by comparing response time before and after system deployment within 1 month. Lastly, customer satisfaction. Citizen satisfaction levels are projected to increase by 10%, evaluated using surveys and service feedback after 6 months.
No excesso de fim de semana, nada vai me parar, nada vai me parar.